So according to a specification in group 1 and 2, we have a flame test. Flame test is used to identify the presence of cations. What type of cations we have. So basically, this flame test is specific for group 1 and group 2 both. Okay. Um, and also, how can we do flame test? What's the method? What's the procedure? So number one thing is that using dropper, add few drops of concentrated hydrochloric acid to the solid. As you know that directly we cannot do a flame test. Let's say I have sodium metal. As we know, sodium is very reactive. When you will be providing direct heating to the sodium metal, it can explode. To avoid this, we have other metals as well. So we never do direct flame test of pure metal. Remember, that's the procedure. So what we do, we make a solution first. We make a solution first. Remember, this is the reason we are adding we are adding hydrochloric acid. We are adding hydrochloric acid to the solid, concentrated hydrochloric acid to the solid, okay? And then after adding concentrated hydrochloric acid to the solid may be lithium, the solid may be sodium, the solid may be potassium, the solid may be rubidium, it may be cesium, anything else. The solid may be any of the sample, okay? So what we are doing, we are going to add hydrochloric acid to the solid sample and mix together so that the metal compound dissolves. Okay. And then this is the reason why we are dissolving in HCl to convert metal compound to chloride. And you know, chloride is more volatile than other salts. Okay. Volatile means which can evaporate easily. So it will burn easily, by the way. Let's say, it's as an example, if I say I'm using any fuel which has more number of carbon atoms. What if I'm using the fuel having more carbon atoms? What would happen? It would not burn. And if it would not burn, so it's mean that it cannot give you energy. So we cannot run the vehicle. So this is necessary to have a compound which has less number of carbon atoms, which can burn easily, which can give energy easily. So same goes for this one. We need a compound which can burn easily, which is more volatile in nature. Okay, so this is why we are adding concentrated hydrochloric acid to the solid and mix together so that the compound dissolves. It would give you better results. Dip a clean metal wire made of platinum, which is unstable, which is more stable, which is inert, which is unreactive, okay, into the mixture to obtain sample. Hold the end of the wire in the flame and observe the color. Like that's the procedure. How do we do a flame test? Okay. Uh, why we are taking platinum wire? Why not any other metal wire? The thing is, let's suppose if I have to dissolve sugar in tea, so the spoon should made of inert metal so that we have to dissolve sugar in tea. Otherwise, if the spoon would be made of the metal which would be more reactive, so the spoon would take part in a chemical reaction. The spoon would dissolve itself as well as sugar. To avoid this, we have to take though the metal which is less reactive. Same goes for this. I want to do a flame test of a particular metal. So I have to take the metal wire which should be more stable, which should be unreactive, remember. So platinum is good. Platinum is good for this purpose. And hold the end of the wire in the flame and observe the color. Of course, it would give you different particular colors. This is the list. This is the list of different metals and their colors. Lithium is this. If you have a lithium sample, it would give you red color. If you have sodium sample, it would give you yellow color, then lilac, then same goes for others. Okay. So you must know this. You must know the color. And then afterwards, the thing is that according to the concept, according to your specification, um, we must know how the metal shows colors. How the metal shows colors. So we must know the theory behind it. So number one thing is that metal electrons are in a ground state at the lower energy level when we have not provided any of the temperature, when we have not provided any of the flame. Okay, so all the electrons are in the ground state. They are at the lower energy level. After providing heat, when you are going to take a sample under the flame, so means that you are going to provide heat. You are going to provide heat to that metal. And of course, as a result of this, as a result of this, um, the electrons will go to the excited state. I mean, at a higher energy state. Okay. Immediately after spending some time, when the electron will return to original state, when the electron will return to original state, so it releases energy. It releases energy which correspond to visible region. So if the frequency is matched with any of the frequency, because different colors have different frequencies, so we can say that I can observe that color. It's very simple. So means that if you remember when we provide strong heating to the iron, it becomes red hot iron. Why it becomes red hot? Because when you have provided energy in terms of heat, basically you made electrons excited, and you can say the electrons went to the excited state, to the higher energy state. After spending some time, when the electron will return to its original state, when the electron will return to its original state, it would release energy. And then we have to see the released energy, and then we can see the color. That's the color theory. That's the color theory. Okay.